let's look back at the concept of coefficient and subscript, but now looking at what that means when we use moles instead of molecules. So, as we mentioned before, subscript tells us the number of atoms of one particular element that you have in a compound. So, for example, if I look at the molecule of water, which has the subscript 2, here it is, I can say the molecule of water that has the formula H2O is made of 2 atoms of hydrogen and 1 atom of oxygen. The subscript also tells us about moles. It tells us that 1 mole of water is made of 2 moles of hydrogen and 1 mole of oxygen. And that we'll see is more useful because you rarely are going to work with one molecule of water, but you are more likely to work with 1 mole of water or in many moles of water because a mole of water weighs 18 grams and it's not that rare that you weigh 18 grams of water. So again, the subscript tells you the composition of the molecule as how many atoms of a particular element that compound has, but you can also interpret it in the terms of moles. 1 mole of the compound water is made of 2 moles of hydrogen and 1 mole of oxygen. If we look at coefficients, we said before that the coefficient of a reaction tells you how many times you have that compound or that atom in a reaction. So here there is a 2 in front of the compound H2, and that means you have the molecule H2, the hydrogen, twice. So you can read the equation in a microscopic level as molecules. You've got 2 molecules of the compound H2 react with 1 molecule of the compound O2 to give 2 molecules of water. But you can also look at these numbers in a macroscopic level using the word mole. 2 moles of hydrogen, compound H2, react with 1 mole of the compound O2, dioxygen, to give 2 moles of water. So you can move between microscopic level, molecules and atoms, and the macroscopic level, which is moles, which eventually you can convert into grams by using molecular mass. It is very important that you remember that the coefficients in a chemical reaction tells us about moles, the moles of the compound we need for the reaction to take place. It doesn't tell us about grams, at least not those numbers in that way. It tells us about moles. 2 moles of H2 react with 1 mole of O2 to give 2 moles of water. Briefly, if you want to look at grams, then you need to use molecular masses. How would you look at this equation looking at grams, not moles? Well, you will look at 2 times the molecular mass of hydrogen, which is 2, plus the molecular mass of the compound O2, which is 32. So that would be grams, 4 grams. So you have 4 grams of hydrogen, you have 32 grams of the compound O2, and that would give you 2 times 18, 36 grams of water. So yes, an equation tells us about grams, but only looking through the lens of the molecular mass. As you can see there, 32 plus 4, 36, Lavoisier principle of conservation of mass is conserved. So again, the coefficient coefficients in chemical equations tells us about moles. How many moles of that compound react with how many moles with that other compound to give you a certain number of moles of the product or products. So moles, not grams. And this is really important that you remember this because if not, any calculation that you do using chemical reactions will be flawed. If you look at, say, at those numbers, say, oh, 2 grams of hydrogen. No, 2 moles of hydrogen that happen to weigh 4 grams, 1 mole of oxygen that happens to weigh 32 grams, give you 2 moles of water, which happens to weigh 36 grams. So this is not going to be hugely important for you, but I thought it was worth spending a little bit of time practicing these information you can get from a chemical reaction, just to make you feel comfortable with the concept of moles, molecular mass, grams, and how to interpret a chemical reaction. So in this, I'm going to ask you to stop the video and answer these questions. If you have 3.8 grams of the compound H2 and you have sufficient oxygen, it doesn't matter how much sufficient oxygen, that all of it will react to make water. How many grams of water would you produce? How many moles of water you would produce? And how many molecules of water? So stop the video now, please. So let's see how I will go about solving this problem. The first thing I need to write or to remind myself is the formula for moles, how to change from moles to mass using the molecular mass. And the formula is this one: the number of moles you've got of one compound is the mass in grams divided by the molecular mass. Another thing I need to remember or look it up is Avogadro's number, because one of the questions asks about the number of molecules. And for that, I'm going to need Avogadro's number. So Avogadro's number is 6.022, 10 to the 23 items, molecules, atoms. In this case, it's going to be molecules of water per mole. So now I go back to the question, and the question tells me I've got 3.8 grams. So I've got 3.8 grams of the compound hydrogen and enough oxygen that all reacts. And it's asking me how much water I'm going to get in moles, in grams, and in molecules. Okay, so then if I look at the equation, what the equation tells me is that 2 moles of hydrogen, dihydrogen, will give me 2 moles of water. So if I have 2 moles of hydrogen, I will get 2 moles of water. If I have 4 moles of hydrogen, I will get 4 moles of water. I have whatever number of moles of hydrogen I've got, I will get the same number of moles of water. So this is the ratio in which the reagent gives you the product. The same number of moles of hydrogen I've got, I will get from water. So if I know how many moles of hydrogen I've got in my 3.8 grams of hydrogen, then I will know how many moles of hydrogen I've got, and immediately I will know how many moles of water I have. And for that, I use the molecular mass. So how many moles of hydrogen I've got? Well, I've got the grams of hydrogen I've got, 3.8. And I know the molecular mass of hydrogen is 2. And this is give or take 1.9 moles. So I've got 1.9 moles of hydrogen. And 1.9 moles of hydrogen, if they have sufficient oxygen to react, will give me the same number of moles of water, because the coefficient in the chemical equation is the same number of moles of hydrogen, that you get the same number of moles of water that you have of hydrogen. So if I have 1.9 moles of hydrogen, I will make 1.9 moles of water. And as you notice, I'm starting answering the question by the second question, not the first one, because the first thing I can find out quite fast is how many moles of water I'm going to make, 1.9. How many grams of water am I going to make? Well, I know that using this, again, this same formula, I know that I've got, how much water will I make in grams? Well, I know how many moles I'm going to make, 1.9. And I know what's the molecular mass of water, 18, the 2 hydrogens and the oxygen. And this is, give or take, 34 grams, 34.2 grams. So my 3.8 grams of hydrogen, which are 1.9 moles of hydrogen, give me 1.9 moles of water, and that water is 34.2 grams. So how many molecules I'm going to get? Well, if I have 1 mole of water, I will have 0.6.022 10 to the 23 molecules of water. If I have 1.9 moles, then I will have 1.9 times 6.022 10 to the 23 molecules of water. And this is, give or take, 1.14 10 to the 24 molecules.